written, but it's just in a different language, right?
Okay, just to warn you, I'm already streaming.
Okay, no problem. Anyway, the thing is that the core idea of the Huffman algorithm, the core idea is that we have an array of bytes, a string of bytes, and the logic to compress this without losing information is to use frequency as the determining factor to 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 create a new representation. So, for instance, if we have, let's suppose just for a moment that we have, I don't know, a thousand letters A and one letter B.
Hey man, isn't that the one that I was telling you? Like you
Right.
transform this string in a list of pairs, and then you have the number of times that it appears and what appears.
Yeah, that's one of the possible steps, because the first thing because the thing that I'm trying to say is that we're gonna use the frequency of the byte itself to represent it in a different manner. In this manner is the smallest possible. So, for instance, if you go to the code, you're gonna see that we have more A's than B's. So we want to make the most frequent symbols to have the least to occupy the least amount of bits possible. So, for instance, in this particular case, we would do something like one. Actually, I need something like this. Okay, so one bit would be the letter A in this particular case. So one of the first steps that we need to do is to calculate the probability of each byte. So if you go to our source of truth, and that would be this file here, the main file in
Are
the
you
.py here.
sure that that's good of an implementation for us to call source of truth?
Oh yeah, this is so simple.
Okay.
Like to go to even to go even simpler than this, you're gonna have to try hard.
No, no, I mean it's not about being simple, but about being correct, like strictly correct.
Oh yeah, it's correct. Oh yeah.
Ah,
I'm
okay.
not saying it's the best implementation ever. I'm just saying that it has the fundamentals. So what we're going to be doing is pick the file, read the binary content of it, and then calculate the probability. I think these are three tasks we need. I want to finish today with at least these three done in Rust.
But what do you mean by probability?
So to calculate the probability is oh, I didn't know GitHub has this. So it knows where this thing is defined. Okay, good to know.
Maybe you
So
could even click to go.
the probability of a thing is basically the amount of times that thing appear divided by the total amount of elements.
But
But
can you
we
call
want to
this a
sort it.
probability? That is the
No,
frequency.
no, but this is it's because we are using how can I say, if you pick a byte randomly from this same amount of content in
Oh,
whatever position,
okay, I
the
see.
probability of being like A, B, C, D is whatever.
Depends
But
on the
there's a catch though.
frequency, right?
There's a catch. We want to ordinate, and this is why I use the heap in this particular case. We want to sort this thing from the greatest probability to the lowest one.
Oh, wait. I see that you want to do that so you can code them in an easier way. But how do you know how to get them together? Like, how do you know the positions when you want to decompress?
No, you don't. This first
What?
step has nothing to do with the compression itself. So there's two steps, main steps that the Huff algorithm uses.
Wait. Is there a point in compressing something if you will not be able to decompress to see the
No, no, no,
actual?
no, no, no. We're not talking the same thing. What I'm saying is, until this point, we are not modifying the original file. The original file is still there, so it's still whatever, how many bytes. We need to do some sort of preparation, and that would be to calculate the probability and the entropy. And with those two things in mind, then we start encoding. And that encoding is basically translating a byte to its specific amount of bits. This is they are divided in three steps. So the Huffman algorithm is two steps. You first calculate the probability and the entropy, and then after all of that done, you actually call the encoding function. So for now, what we want to do, we want to discover how to do I/O operations in Rust. So that would be to read a file. We want to read it byte by byte, and then after that, we need to do a probability. We want to calculate the probability, and this probability needs. It would be nice if it's already sorted from the greatest to the lowest. This is like I said, I use the heap data structure here because it already does this naturally for me.
Okay, what is the heap exactly? Can you describe
Heap
to
is
me?
a heap is a binary tree. So tree, heap tree.
But do you represent that in an array?
No,
You can
heap
do that, right?
is a tree. You can do a heap as an array, but that would be a real pain in the butt because you kind of need to maintain
Yeah,
this.
but then you have constant access, right? So
Yeah, you're gonna use the index as a way
yeah,
to
I
like
remember you do a
travel.
bunch of like indexes divided by
Oh, like
two, right?
this.
Oh, okay.
And this is bad. I wouldn't recommend this.
Well, it's hard to implement, but maybe it's
Yeah. Yeah, this is exactly this is something like the heap. The heap has the property that we want, so that will be to have a way to sort it naturally because we can do in two steps. This we can like calculate the probabilities and then save like a
hard.
tuple. We can save like a tuple, for instance, and then after that sorting. But then, well,
Well, we could do it in a step, right? Then would be better.
yeah, we could do if we use the right data structure. We could do it in one single step.
Wait, Lemos. But there is a thing, man. You could do it like a list, and the thing that you would do is to like insert in a list that is already ordered. And what you would be able to do that because initially it would be empty. So that's another list.
No, no,
But
no.
the
But that's the
thing
thing.
about that is the access, right? You are
No, but
carrying. Okay, go.
no, but that's the thing. When you using a heap, this data structure already like. Let's suppose that you put the lowest first. So the lowest probability comes first. It's like on the head of the thing. And then when you add the one that is greater than the first, the heap, when you do a push, it already like modifies itself to balance itself, and then it already corrects the order.
Oh wait, it's because you want to use like the standard library to already get this order instead of implement you
Yeah,
want.
when I did in Python, I discovered that structure was pretty handy because I could just like I didn't even care if this was in order because this is a natural property of this.
Okay, I see it.
And it's like it's not bad to do like O of 2n, but we kind of want to be fanciest as possible. So O of n would be nice. O of n, big O. Okay, so that's exactly what you're gonna do. Right now, what we need to do, we need to
Uh
discover how to read things.
no. Before that, I would like a sample file. Sample.
I think I do have one in this specific repo. Let me check. Oh no, I don't. Okay, good to know. Um, um,
Could start
let
like with a hard coded name, then we could like pass via CLI, right?
Is this the one? Oh, is this the one? Oh yeah.
Holy fuck. That's quite a text.
Okay, so let's do this one. Uh, okay, I can't copy into here. Why?
You should be able to.
Nice.
What?
Okay, No, and just to make sure we are on the same page, reading a byte is not the same as reading a letter, right? So, for instance, the byte of of the accent.
Uh wait, depends. It depends on uh,
No, for instance, if you read this file here, on line 7, we have this accent here. This is not gonna be in the representation. Like the byte for this is, I don't know, 0x, I don't know, 194 or something like that.
uh,
Like it's gonna be a real it's gonna be a don't be afraid to see a bunch of bytes with nonsense, because it's natural.
uh, what I mean is that we could use, like, if you are reading as bytes, right? If you are doing a get bytes or some, uh, they are char in some languages, like
No, but this
unsigned 8 bits.
Yeah, but this
So
is not sharp because we are not in 255. There's
uh,
more 255 things here than the characters. They are just what I will call normal characters. For instance, accents are not normal characters. Letters with accents.
no, no,
These are not normal
oh,
characters.
okay, I see, I see. You are saying that this is not on ASCII, so we could
Yeah,
read as
this is
UTF-8.
Unicode. This is
Okay,
Unicode.
yeah, like if I, yeah,
Mm, read bytes from file.
what do you mean by get file name?
Because when I did the original version, and I think it's a pretty cool thing for accelerate debugging, we first provide a file name. So in this particular case, at the end, we're gonna provide doncasmurro.txt. But this is gonna be basically the entry point of which file you want to compress and decompress.
Okay,
That's
but in
basically what
this
we want.
case, you will only return a string? Is that it?
Uh, yeah, in this case, this is the function that will like prompt the user like a message to pick the I don't know, put the file name on the directory or something like that.
I don't really like that API language. I would prefer to pass as an argument, but before we implement that, I would prefer just a string, man. Like fix it in somewhere. Because well, we don't need to prompt someone. We can call the program with that string, as
For
we
me, it's
do.
fine. For me, it's almost like whatever, like command line or passing with a prompt from the user to the user to put. For me, whatever. The thing that I want to know is that it's about types. So let's suppose that we want to do what you said. So we want to have a string. How we do that? Is there something like a string?
No, no, just
str?
no, no. Wait,
Oh,
wait.
oh, this is
Just
probably a function, right?
I don't think so. Maybe it is. But man, just use the same as in F sharp. Like let something equals
Oh,
string.
there's lets in here.
Sure. You never saw like the syntax.
No, this is gonna be my first day. Oh man, there's even the mutation, the mut word. Okay,
Man, I haven't
word
I
file
haven't
name.
how is it? I haven't read about yet, but you have like different kinds of string. You have like the type string. You have a slice of a string that it's called like
Use
it's like I don't know how to say that, but like what is this? I use general or project, right? Yeah,
uh,
like you have those two types. Well, that I know of. See,
is
the
the
first,
first a type? Really?
yes, if I'm not mistaken, it is a type, and that would be the default type if you just assign a normal string.
Okay, so what's the difference
Okay,
between
your
those?
extension is not working, I guess. Maybe it's because you are sharing.
What do you mean?
It should be giving you type and some stuff. When you hover like file name, he's not also. Can you
Oh,
try to
okay.
do like, oh, reload required? Oh, okay, you went.
No, you were kicked it out. Okay. See if you can open it. See if you can open the link again. That would be nice.
And
Yeah, the hover is not working still. Failed to discover workplace. Okay, so the Rust analyzer is broken apparently.
maybe it's because you need a cargo project. And hey, we should have done this before.
Oh
Oh
yeah?
fuck yeah.
How you do
Okay,
that?
okay. Go cargo new and the name of the project.
Cargo new Huffman.
Yeah, but then we don't really
Oh,
need like Ruffman.
wait. No mode, wait then. Uh,
We could go back and
uh-huh. Uh, okay, so now it's complaining about.
permission them.
No, it's because I am with this open here.
Okay,
So, okay, so now let's do like this. Still permission denied.
but he deleted, right?
Yeah, but I don't know if it's still grabbing it somehow. Let's see if I can force it. Okay, I can't force it. Which means that someone or something is using this thing. Oh, here. Nice. Cargo new Huffman.
Now you
Nice.
can just do like cargo run, and he will build and run for you.
Nice, nice, nice. Okay, but the main idea here, the main idea is to, like I said, is to make the things that happen more frequently to consume less space. But there's a little bit of an overhead. Like we need to pass this because at the end of the day, we're gonna have a dictionary, right? We're gonna have the byte that should be there, and its bit representation. We need to
What do you mean
send
by
this.
bit representation?
Let's suppose that the letter A is like 5 bits. You need to say that somehow. You need to say to the compressor, anytime you see 5 bits, it's gonna be the letter A. So substitute these 5 bits for like this byte that is correspondent to the letter A.
Not sure if I'm following that.
Because okay, so can you enter the thing still?
I'm already in the. Oh no, I'm not.
Yeah, you're not. I
Wait,
think.
but I can see your screen.
Okay, but the thing is, we have a bunch of characters. No, can't be that chaos. Okay, like this. We have this. Okay, so we're gonna do an algorithm that will determine that the most frequent character will have the least amount of bits. Because right now, every single letter occupies 8 bits, right? So for instance, if you go to here and put, I don't know, ask table,
You can do on your terminal, like man
you're go-
asking.
you're gonna see that like everything is between 0 and 255, something like that. And then this means that everything occupies 8 bits. So we have 8 bits for all these letters. So 1, 2, 3, 4, 5, 6, 7, 8, 9,
Okay.
10, 11. So 11 times 8. So we have 88 bits. We want to make this smaller. And the strategy that we're going to use to not lose information along the way is to make the most frequent characters, the most frequent bytes, to consume less than 8 bits. There's a strategy for that.
But
That
now I would ask you, that bit pattern that we use, that an arbitrary one? Is just a tag
No,
that you will?
that is no. It is. It's not an arbitrary because we need to make sure that they are unique. You know,
No.
because
What I mean by arbitrary is you will like select a bit pattern for each of those.
yeah, I will. But
So
imagine
it's
that it's
just a
like this.
tag, right?
So imagine that the 1 bit is the letter A and 2 bits is the letter B. How are you gonna know that this is this or this? So there's a smart way of classifying this, and that would be to make it like this. Uh, so then you're gonna be able to always be able to know that this sequence is actually this. and so on and so forth. So I don't know if we're gonna go into this specific part of the algorithm today. Maybe on Tuesday, Thursday. What we need to accomplish now is we need to have a way to read content from a file. This is what we need to do now.
Okay.
Okay, so um, I don't know. I'm gonna create something like close to IO because it's inputs and outputs, right? So we're gonna have when to read an input. We want to read a file, an external file from
That's
the application.
far better than duties, you know. So how to read a file in Rust?
uh, how to read a file in Rust. Okay, so
Nice.
there is the same function in C that it exists in here. Cool. Open, it's exactly the same function even, which is cool. Uh, read up to 10 bytes. Buffer. Read the whole file.
Oh, okay. See on the line,
Okay.
let mute buffer.
Yeah.
That syntax is saying, I will create an array with with filled with zeros, and I will have 10 zeros. So it's an array of length 10. That's
Oh
why
man.
it read up to 10 bytes.
Yeah, but what if I want to read everything that is not will not be contained in 10
Yeah,
spaces? I
then
don't
you
know.
cannot allocate a static array. It's probably like, I don't know, either a vector or some
Hmm.
buffer type.
Hmm.
Because I would think
Oh,
that
it's
would be
like this.
a
Nice.
stream.
It's like this.
Yeah, but that's strange. I would expect a stream thing, no?
Okay, is this a type? What exactly is
This
this
is
first
this
line?
is the return. So fn, so function main,
Okay,
and
okay.
the parentheses because you don't have any argument, and
Yeah, this
then
is units basically.
not really. It's not. No, it's not unit. Not unit.
Okay.
You could put unit inside of this. Uh,
Oh, like this?
uh no. The syntax is name and colon the type. So you could receive a of type unit inside main. Like
Uh,
a between
anyway,
parentheses.
I still can see the type. You said that hovering should add me give
No,
me
no,
more
no, no.
information, right?
Not even hovering. He just shows you.
Yeah, here is not showing me anything.
So try to reload again now that you are using cargo. Like with no with
Extension.
reload I mean Control Shift P
Control Shift P. P.
and then reload
Okay.
win.
Reload. Reload. Window.
Right then. For me it works. Do you
I
like
can do some offline debugging just for this, no problem.
do you like an enter uh, and save like not on random things that break. Save that trigger. No.
No, but it's running down here,
Oh
you see?
yeah. Okay. Can you click this to at some
Now
stage?
there's a loading, whatever.
Oh, okay,
No,
nice.
no, no, but now it vanished.
What the fuck?
Is this running forever, maybe?
Wait, can you click on that Rust Analyzer? Did you
Here?
install only this one? Yeah. Oh, cargo. Oh, okay. Try to build it. Maybe it's because you need to build it. Like cargo build running from the root.
Cargo build. Okay, cargo build. Whoa, this is not gonna work because I need to do
Can do
stuff
it
like
on.
this. Okay. Hmm.
Didn't work now. Try to reload it again.
What a fun experience.
Oh, try to do the enter thing also. Refresh. Nothing. Just reload. Oh,
It's no, it's saying loading. Reload window. Last attempt to do this. Okay, but anyway, is this a type? Is this a type for what we want
Yeah,
to do?
it's what I was saying, man. After the arrow, you have the return type.
What is this?
So, okay, this is you accessing the IO namespace. So the
Oh,
IO,
namespace. Okay.
yeah, so you have like the standard library, and then there you have IO. And on the IO, instead of doing IO dot something, you do this double column. And result is a result type, but is a IO result type. What that means is a different kind of result. You could take a look on the documentation and you see what are the cases for.
I think this is a. This seems parametric typing, man.
What do you mean by?
Because like there's a parametric polymorphism
Oh
says
no,
that you
okay,
have like
okay,
a type
okay.
A, like random, and
No,
then
no,
A,
I know what you mean.
like
So
this.
yeah, but what I mean is that is not the result that you would expect. Just you see, like result uh have two generic types. There we are only passing one. You see,
Uh,
so
where
it's
would go the two? The second, sorry.
it doesn't have one. That's the thing. It's not the result that you are used to.
Oh, okay. So this is just a new name for a different thing.
Yes,
Okay.
it's the result type of the IO namespace. So it's not the same normal IO that we are using.
Anyway, can we create something like read file? That this should work, right? And then this is gonna be
Yeah, I
this.
think you probably will need to do some imports there. Maybe you are uh, forgetting.
How we do the imports? Use IO.
Yeah, I'm not
It's
sure.
like this.
I'm not sure, and I think you need like
Oh, these imports. Good to know.
yeah, you need there.
But how we insert? Oops. Okay. Okay, but how do I put my own files?
I don't know, like
How to
port
import
module.
files Rust? Oh,
Oh, okay,
you
okay.
actually have to create
Yeah,
like a
it's a
module.
module.
Okay, so let's do. Oh man, I'm using Emacs shortcuts. Uh, will be something like this. What's the difference? Oh, the pub is probably like a modifier, right?
Yeah, it's because you can access, right? You can import that. The address would be like private.
Nice.
Oh,
Okay.
wait. The module name.io. Yeah, and then you just do like use IO, and then you can access like IO read file. Right? But it's
You.
not with dot. It's not with dot. It's
Oh. Oh, like
column
this.
column. Yeah, I think so.
Okay, and then we have. How do we do this? We put string here.
Uh, okay. Between parentheses, you put the name of the variable.
File name.
Yeah, column and the type.
File name. And then the type I put like with a space.
No, no, column. Like
Oh,
normal
column like
limit.
this.
Uh, like it's the same thing, most of the same thing that we are used to, like in other languages.
I
Oh,
wouldn't
okay,
say
but yeah,
so.
don't use. I don't think that's the correct type. I think it's the other one that I showed. Like,
Can you repeat the difference between those?
yeah, this is string type. It's a more complex type. I guess he's not like primitive, and this one I think is a primitive. So okay, this one have a fixed size. The other one,
Mm,
it's mutable.
okay, so now a second question: is the
But
scope of these
hey,
files?
uh,
Wait, go
yeah,
say.
if they are on the same level, I think you can just do the same way. But you need like ponto e vírgula, you know?
Oh, semicolon.
Yeah, semicolon. And I think that's why it's not working. You see that you have run and debug there. The extension
Oh,
is working.
here.
Yeah. Now if you import properly and save it.
Yeah, but there's a problem in here.
Oh no no
Whatever
no
this
no. Wait.
is.
That's the,
Expected one of this. Found the keyword.
yeah,
Oh,
man.
I need to
That was
save it. Oh, I need to
yeah.
save it. Okay.
Now go to your terminal and
Wait.
run.
Let me pick again Dom Casmurro here. Okay, I will just I don't know throw at the here. I don't know how what's the scope of this. So this is gonna be txt because we okay terminal.
Yeah, and do like cargo check. I guess.
What this does?
He checks your.
No external crate. Unserved
Mm.
import.
So you need something when it's like a file that you have. So take a look on Google.
But that doesn't make sense.
Sure, it does.
Oh no, this is this is the guy complaining. We are dumb.
Oh yeah.
Okay. Oh, oh, you need to put like
Oh,
this. Hmm.
wait. That's weird. Yeah,
Okay, so it's
that's
not
weird. But
use.
okay.
It's like this.
Oh, okay.
So you do
Mod and the name of the file.
IO,
Oh, okay.
and
Then we
then
don't need to
here
just
we don't
normally.
do this. We do like
Do we
this.
still need the pub thing?
Holy man. Yeah, this guy says yes.
Okay. What is
But now it's
wrong?
complaining all of. Oh, it's because I need to save the thing.
Sure.
Okay.
But hey, do you have your types? Yeah, I do.
Hmm.
Oh, okay.
Okay, so
Yeah.
unused result. Oh, it's because this is not returning unit. This is returning result. So let's do something like
Wait.
file
Before
content.
that, change the names, man. Like read file, put on snake case as the effect. Oh, see the
What the
types?
fuck? What the
See the
fuck is
types?
this?
The types, man. But hey, snake case. Snake case.
What are you? Snake case? You mean? Wait, snake case? You mean this?
Yes.
No. You're gonna have to kill me first.
No.
Hell no.
Rust will kill you.
Oh man, but this is so bad. This is Java inspired. We're gonna go to hell.
No. What do you mean, man? It's just
This
as good.
convention, this name convention here is the this is the convention most used convention in Java projects.
And in C, camel. Well, it depends, but I
Oh
think
man, it's so
it could
bad.
be even better. But for now, let's go with it, just because we have a bunch of compiler
Oh,
warnings.
so bad. Okay,
Okay,
I need to change this back.
Lemo. So something that we can use, uh, in Rust, things works kind of like in F sharp, where you can do like your value dot something, right? Uh,
Wait,
hmm?
I don't want. This is wrong, isn't
No.
it? Because this is returning OK. I don't want an OK. I want the content of the file.
Okay, yeah. Then this is wrong.
Okay, so do I have a write all bytes? This seems promising.
Okay.
Is this a function probably like this?
Yeah.
So, but now this is kind of broken. Can I see the types of this
Man.
function?
The types of your return you didn't change. Yeah, you can see when you
How can I
revert.
change? How can I? Oh, here. Okay, so bytes. So there's this thing called bytes apparently. So it's not result here. It's bytes
No IO, no parametric type. I'm not
like
really sure.
this.
Well, things should be working, but I don't think it should.
Okay.
Yeah.
Not found in this scope. Okay, so apparently there's a way.
Lemus. Uh, maybe we should receive Lemus. Maybe it should return a unit and it should receive the buffer and then it
Oh
just
no,
writes the buffer.
but that's a so imperative way to do things, man.
Yes, yes.
Holy Jesus. Uh, okay, that can work. Not against necessarily. So this is the file content. It needs to be mutable because we're going to change it. And can we do match in here?
Sure.
Oh yeah,
But what do you want with match?
I want to go back to. I want to do Control Z. Yes, like this. I want to do like this, but because the type of whatever is this function, I think it's like
Wait, wait,
error or
wait.
result, if I'm
Uh,
not mistaken.
you have to wait a bit because we don't know yet if we actually need this result.
We do need the no no. We're gonna use the result to see if things go into like match okay, and then we continue. Match error, we just throw an error.
No, no, but right now we are returning this okay. Right?
Buffer. What's the type of this thing?
I don't that.
It's a vec of unknown.
Ah,
Okay, I kind of want to make it a vec of bytes. Can I have a vector bytes like
I
this?
think.
Oh,
No, no,
oh,
but wait, wait. That doesn't mean anything. You want to see on the calling side, and you need to remember to save those files, man.
yeah.
Go to the
Uh,
calling side and see if it's okay you passing file con. Yeah, but what is the error?
no clue. This function takes two arguments, but one more supplied expected two. Interesting, interesting. How can I type this better? I kind of want to make it like this. Now it's a boolean. Oh.
What the?
Okay, let's try vector of bytes in Rust. Bytes. This is not what I want. This is still not what I want.
You have to take a look on the types, right? Like, what is a byte?
A byte is a representation with 8 bits.
No, no, no,
Usually,
no,
not
no,
not
no, no, no,
usually.
no. I'm talking about the types, not the concept of a byte.
That's true. But how can we make that? How can we make that? You know
Question.
how? Oh, there's a match here. This is exactly what I want to know. I want to do.
Probably, maybe not lemon. Like, Rust have some other things that we can use.
Oh, it's U8. Okay, so this you guys don't you know this is so low level because U8 is unsigned 8.
Yeah.
Okay.
You see, so byte is a more complex type, right?
I don't know if I would call it more complex, but anyway.
Well,
How
it's probably like boxed or something,
no yeah, there's the chance of being like that. Okay.
not a
But
primitive.
now it stopped complaining. No, it's still complaining. Comparison cannot be chained. What is this? Is this a lack of parentheses?
No, 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 no. Don't even start with that. Maybe you need to pass like the the type parameter after the like column. Yeah, and that could be
Oh, like this?
no, 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 no. But between the
Are you kidding me? This can't
not
be
here,
right, man.
not
This
here,
can't be
and
right.
you need dot not dot new, right? Wait, is it dot new or column? Oh, I
Oh, wait.
but
Let's wait a
no.
little bit.
That's
Yeah, it's so.
no, no, no,
Oh
no,
man,
no.
this is terrible.
No, there is something wrong in there.
Yeah, but this is yeah, it worked. It's a vec of unsigned 8. Holy
Hey,
Jesus.
hey, no, 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 stop that. Annotate the file content as vec8.
Oh man, that's terrible
And
syntax.
and then and
Holy
then
Jesus.
remove from your line. No, no, only new. No, man, that will not happen. Like vec vec new, but without putting a type, right? So does that works?
Still terrible.
No, no, much better, man.
Ah, better, but it's still terrible. Holy Jesus, man. No, it's this. We want something like this. Okay, okay. Now we're talking. Okay, but then there's this.
Wait,
Whatever it
Lemos.
is.
Uh, Look at the type of this. At the type of read to end.
It's a self,
Oh,
and then
result of u size. Okay, that's probably if goes okay, then it's the amount of bytes that you have. So that will be your result. So like remove your fucking okay from there and return the result u size.
uh, return what?
Just return the like return of the read to end. Just remove the
There's a keyword for
semicolon.
that.
No, no, yeah, you can use return, but don't use that. Yeah, just erase the return, yes, and then change your return type.
Okay, so this is U size.
U size, yeah, but remove the IO because now we want the normal result.
Okay, so
Oh wait,
um,
now I'm not sure. Go to the type again of read to end. Uh,
it's uh it returns result U size, man.
that's weird because if that's the normal result, I would hope for two types, right? Well, scroll down.
Holy Jesus.
Examples.
Probably gonna be the same as before.
Fuck me.
The same as before. Um, no, but that kind of doesn't matter in
Oh
my
wait,
eyes, man.
wait.
Yeah, but no,
Wait.
but this is wrong. This
Remove.
is not what I want. This is not what I want. What I want is the okay. I
No,
want the
no, no, no,
okay.
no, 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 Lemos. The okay will be your return. Man, see those question marks? They are doing something. I guess they are maybe ignore something. I don't know, but well, take a look on what they mean. Rust operators. They are probably doing
Error propagation.
what that means.
Is this a monad? Oh no!
Don't even start with that, Lemos.
This is a monad, man.
Error. Oh, I guess they are doing like if it's error, then throw.
Yeah, this is a computation expression.
No, 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 no. Just
Yeah,
remove those.
if you start with something and then you get an error in the middle, the first error will like short circuit this entire block.
No, 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 Lemos. That is if it's an error, then throw it.
Yeah, it's not gonna come. For instance, if you have an error here, it's not gonna do this in this line.
Okay, Lemos. Remove those question marks. Uh, okay, now we have result. Uh, okay, we need files. Okay, do like dot and expect, I guess. Dot expect.
Where?
After
With who?
after the open. No, no, no,
F
no,
dot.
no, no, no. The expression for the semicolon. Dot and expect, and then like do a message in case of error.
With inside parentheses like this. File not found.
Okay. And then you have the f, and then you have f read to n, and then you just return that, like return the return of read to n. So
How do I
okay,
do that?
that way, that's it.
Use size.
Yeah, that's the tricky part. I'm not sure what it should be the size of it. Let's just try. Oh, that works.
No.
Where is the problem? You're not.
Oh wait. No 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 no. Wait 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 wait. This is already mutable. I think I need to say this here, like this or something.
Oh, okay, okay, but it's a reference. You need, yeah.
Okay, so this is not like this. This is this. Okay, let's wait a little bit. It's loading. Oh yeah, now it's wrong here. So mismatched types. Expected struct v8 found mutable
No, no,
reference.
no. That should be on the type. Yeah, should be on the type, not on the name of it, I guess.
Oh, here? Like
Yeah,
this?
guess so.
Oh man, that's terrible.
I don't know what you are talking, man.
Okay, let's wait because it's loading the errors. Uh, oh, it seems to be correct. Okay, now the error is in here. I don't know why exactly. So consider multiply borrowing. Oh no, this word. Consider multiply borrowing here.
Oh, no, no, no. Okay, because you are not passing the reference. You are just passing normally. You need to just
Oh,
like put.
I need to do like this.
Yeah, but with mutable, right? Like
How
this mute and then space.
like this?
I guess so.
Okay, so there's a difference between mutable and holy Jesus, what is this now?
Now it's because you are not handling with the result.
Okay, so this is gonna be a.
No, 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 no. I don't know. Like, do you have some treatment in the case of that being error? I don't think you have.
We should terminate the thing if you
Yeah,
have an error.
then just use the expect dot expect.
But we already have an expected here, man.
Yeah, and we will just use another one. If it's okay, we get the
Uh,
value. If it's
why not a
an error,
match?
because we want to terminate, and expect does that with an error message.
Can't we terminate with a match?
Sure, but why would you? Would be the same as doing expect.
Because we are kind of making things one-lineable, man, and this is the recipe for
No,
for
no, no, no.
for.
It's because you are not formatting. I think your format is not working. Can you do like Control Shift P?
Again.
Yeah.
I don't want to throw an error message here. I just
What
want to
case?
expect.
No, no. And then you need to use unwrap.
Unwrap
Yeah. No, no. Just unwrap. Dot unwrap instead of expect. You will just,
like this.
I guess. But what is the problem? Well, save it, man. For God's
No,
sake.
the problem is that it's not being used.
No, 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 no.
It's not
Now
being
it's
used.
fine. You see? But hey,
Uh,
Control Shift P.
let file name. Uh, this line is so Jesus ginormous.
Man, but
File.
that's because you're not formatting. You could go like cargo format, I guess. But I would advise you uh, to make your editor do that for you in faster.
Okay, is this working as I want? Is it this Oh, it's because of this. Okay,
So hey man, Control Shift P,
Ctrl Shift P.
and then go like open settings JSON, and then you need like save format on save, I guess. Can include the end of it.
No, I don't think is that's how it works.
No, no, it is how it works. Like you can go.
No, I don't think
Oh, you
so,
have
man.
that. Okay, have that.
Uh,
But
I
why?
would use the same configuration.
I don't know why do you need all of this, man. And why do you have format on type? That that doesn't sound good.
We can here.
Okay, yeah, that's reasonable.
Okay. Um,
So save it now.
I
Okay.
save it.
Formatting. Format.
Is that in German? This is not done yet?
What do you mean?
Is this is it this formatted?
Yes, I guess so.
It's the same thing.
Yeah, because in this case, like save the other file, the IoT.
Still
Okay.
the same. Still the same.
Yeah, it just reordered the imports that you had. But
Yeah.
if you have a long enough line, they will break for you. Don't worry.
Okay. Okay. So we can test this now, right?
But you are not printing.
Kind of doesn't matter right now.
Well,
Cargo.
it's compiling. That's what you want to see. Well, check is already like if it's built.
Okay. How can I execute things with the
Cargo run.
cargo run?
Just that is as easy.
Okay, so it's definitely not doing anything whatsoever. We need a way to see this. Okay.
Yeah, but you are not.
Print. I think it's ln like this. I don't know what this
Yes.
exclamation mark does, but
It means that you are like invoking a macro or something. Yeah, it doesn't work that way. You need to pass a string with placeholders. You cannot just pass something.
what I put in here?
The placeholder is like uh, curly brackets, like open curly brackets, close curly brackets. Yeah, and it's like a printf. You do like another argument, and the argument would be what you want to show.
Like this?
No, 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 no. The other argument.
Oh,
No, no,
file
no, no, no.
content.
That's a string. That's the first argument of println. Man, that's a placeholder. Like you will do like
Yeah.
comma after the string.
File content.
Yeah, and then if I remember correctly, they have to implement like a trait of display to be able to print it.
It's just probably the same thing as a type class. Okay. Oh, cannot be formatted with
Oh,
default
okay, okay.
formatter.
Inside the formatter, inside
It's
the
exactly what you said. It's exactly what you said, Hey.
yeah, okay, inside the placeholder, you will put like column and then question mark.
Like this.
Yeah, try this. Hell yeah. Oh, that's like the percentage uppercase A in F sharp, I guess.
uh, yeah, this is not the byte, right? This is a straight up conversion from the byte to the decimal
Yeah,
integer, whatever.
I guess you could tweak the
Ah, it
placeholder that
doesn't
you are
matter.
using.
Kind of doesn't matter. Okay, so we know how to make a file, how to read a file, not how to make one yet, but how
Oh,
to
hey,
read
hey,
one.
by the way, you are using, as I said, unsigned A 8. So that's a charm. Man. So for you, you are getting the characters. And if it's an UTF, it's okay. You cannot like really print the thing. But yeah, it's kind of a charm.
Uh, okay,
Nice.
okay, so this kind of work. Now we need to make a new function inside a new file that I don't know how I'm going to name this. What's the name of for this, man?
I don't know. We could do everything in this file and then like refactor.
I kind of don't like because this is not IO what we're about to do, but we can. I don't know.
Wait, what is the thing that we need
Fn,
to do?
we want to do something called calculate probability.
Wait, wait, wait. Snakehead.
Oh yeah, oh that's terrible, man. And we need to receive. What's the type of this crap?
Of what?
Is a result use size. Okay, so we're gonna receive whatever this is.
Oh, wait, wait. If you don't need to, well, if you don't need the thing, you don't receive the thing. Do you need to know the size of the array of bytes?
Mm,
How many bytes do you?
no, we kind of just want to have like a vector. Actually,
You
it's the
just
same
want
type as this,
you
right?
just want to receive the thing, right?
So we do have a buffer, and now we want to we're gonna
Wait,
create
wait. Not
new.
mutable though. Not mute. Oh, wait, 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 wait. Uh, if you pass as immutable and it Can change? Yeah, I don't know. Leave it like this because I think if you pass as immutable, he will complain.
Yeah, no, that's no, but that's the thing. We're not gonna mute the vector. Actually, it doesn't matter. But it's this, it's the file content. I'm passing mutable here because I will use the file content again.
Yeah, even if you will not mutate, I think he requires you to pass in a mutable.
Okay, so now what we need to do, we need a way to calculate the probability, and would be nice to have like a heap in Rust, box, stack, and heap. Oh my
No, no,
god.
no, no. That's not what we wanted. Wait, maybe it is.
Heap allocated rectangle.
Yeah, no, it's not what we want.
What is this box
This is
crap?
talking about the like memory layout of Rust, like heap in that sense.
Oh no.
See, like if the
This
thing
is
is like,
not what we want.
yeah, what they mean is like dynamic
Oh, here,
allocation.
collections. This is exactly, this sounds what
Oh,
we want.
binary heap, right? Oh
Yeah.
hell yeah, it's the same, man. It's just the same.
Okay,
Oh,
so
that's nice.
what we want is something like this. Um,
There you have it, like binary heap, then method new.
okay, so we're gonna. Is there any sort of like do we use list comprehension or fors in this crap?
Uh, what do you mean? Oh, we have
Like,
for in. We have for in.
okay,
For
Python style.
x in, yeah, iterator.
Python style. Okay. I kind of want to add a type annotation to this thing. Binary
Why?
heap
Why though?
because it's
Oh, it's a no. Okay.
um we want.
Is it?
Can we control? How do we control the? Oh, that's a tricky question. I don't know if you know the answer.
What do you mean?
Because we want to organize, we want to balance the heap using just one of three things. Okay, let me try to exemplify with some
Man.
examples.
You need
Here,
to.
here. Okay, so we need to put the nodes in the heap will be a tuple. The tuple will be the probability itself and the element itself.
Oh, but you want
But
to
we want to
balance through one of
using just the first.
those.
In
Oh.
Python, the first on the tuple is the one chosen to balance.
Lemos, I guess I have a way that I can think of, but we would need to implement some things. You could do passing a record of one and the other, and
Okay,
then you would need to implement a trait of ordering for that record.
I liked it. It's basically implementing the OR type class. Uh, Recording this.
By the way, thanks for giving me the context on type classes because now I can see that like we have that everywhere.
How do we do records on this thing?
I don't know. Like, just
Um,
search for records in Rust.
okay, how
Oh,
to
you were
make.
already doing that, right? Okay, no. I have a better idea. Search for Rust book. Rust book. Yes. Okay, then we can go there, like struct 5. No. The fifth one there on the menu of the left. The fifth. Okay, just pass this. Oh, we have no. Search for Rust by examples. Oh, we need that. We need that for our life.
We need that for a life.
Yeah,
Oh, I know what this is, man. Zozin used
yeah.
this
That's
in
really
the
good.
last video. But I'm not seeing. I'm not seeing
Types maybe.
trucks
Well, go.
types.
Yeah, go.
Casting
No,
using type interface
no.
alias for types.
Custom types. Custom types. See the third. Oh yeah,
Struct
structs. Yeah, probably so.
structs.
Mm.
Is
Oh
this a
no
no?
no
This
no 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 no
is this what I think it is, man?
no. This is, I guess, is the same deriving that you have in Haskell. That's like
Oh, fancy.
automatic, automatic,
Yeah,
right? Yeah, but
No,
I
look at
think
no, but
you have to implement by yourself.
oh, but that's shitty. That's a shitty version.
No, because how
Yeah, it
can
is,
you?
man.
No, 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 it's not. Because how can you
Yeah,
know that you will order by one element of the record?
I
That
don't
is not the way.
care. I don't care how it's gonna know. I just
No,
wanted to
man.
know by. I don't, man. People don't understand what exactly types tree. Do you see this? Do you
Mm,
see this?
sure.
I'm. Do you see what I'm
Okay.
deriving
No,
here?
no, 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 no. Lemus. What is
Oh no.
Lemus? What is the order in there? If you have a record that you want to compare by one of its properties, can you derive that ordering? Can you do that? No,
Um,
you can't, man.
no, I'm just messing around with you before.
Oh, okay.
This is a very well-known data structure in like the whole computer science. This is why Haskell knows how to implement the functor and the foldable of a binary tree.
Yeah, but that's quite impressive, actually. Like,
Yeah.
yeah, because the show and the equal, I guess, is like, well, easy, right? But the other ones,
No, but
okay.
you can, for instance, you can control the order. So if you want it to do things first on the right subtree instead of the left, you just change the order in the record.
Oh, okay.
Yeah, it's fancy, but this is exactly what we want. So let me go here.
Yeah, but no derive though.
Heap. I kind of want to derive. I kind of want to see what this is all about.
Oh, okay. But
Uh,
then you will search for the ordering or comparing trait.
what's the debug one? What this does?
I have no idea.
Nice.
Wait. Doesn't make sense you call this a heap and put
Yeah, it
the.
is a heap.
No,
It is
no,
a heap,
no,
man.
no, 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 no. You have calculate probability there. There is no sense in you calling this a
It
heap.
uses a heap.
No
It
way.
will return me a heap. It
Wait,
will this
Lemus,
calculate probability will return a heap.
look at the name of your file.
No, it's just temporary. I don't know what's the best name for
Oh,
it, but for
okay.
now it's heap because it's heap related stuff.
Oh, okay, that's fine. Uh,
Maybe I'm lying also, but uh,
oh my god.
Hypno. Okay, so the first will be the probability itself. How we do doubles on this thing?
I
Double?
I don't know. No,
Is
no,
that a
no,
thing?
no, no. I guess it's like. Wait,
Uh,
actually, I don't know. Maybe it's float.
symbol.
Oh, float 32 or float 64. Man, I love Rust types. No, no, no. Everything like lowercase. Oh no, F, just F. I guess it's just F, just F. Yeah, I love that.
Oh.
Does it need to be that big? Yeah,
Um,
you want
no,
precision, right?
it kind of doesn't matter for this specific algorithm that we're making. Like
Okay.
it only matters when like we have a really close distribution of symbols, and this is pretty rare in human text. So because for instance in English we use a lot of vowels, for instance. So it's pretty unusual to have like a balanced amount of characters.
Actually, we have a kind of a law, right? To not sure if you can call a law, but to describe, is it like zip something? Let me get the link.
Uh,
Zip distribution, maybe. Like,
why is this not compiling though?
have the compiler. Oh yeah. Let me get for you on Discord.
Um, we also need to make sure that the Rust whatever thing is going on here.
Okay,
This
I
is
just.
wrong. No, but this is I think this is wrong, man.
What is wrong?
I think this heap is dumb. Some now pick shows the most important item in the heap. We can check the length of the heap. You
Stops.
can iterate. You can iterate. I want to iterate through the heap just to see what happens because I don't know if it's actually sorting the things out for me.
Lemus, I guess you need to.
Ooh, there's the mean heap. Is there a max heap?
Well, that's probably the default one, right?
because I don't want the min. I want the max. I think
So I guess that's the one that you already have. But Lemus, you need
either
to implement a trait for ordering, I guess.
we're gonna do that. Just I just want to understand the. Yeah, this is the reverse that what we want. We want the opposite of this. Okay, but I want to know why this is complaining.
Okay.
Oh, it's because I don't have the trait.
Oh yeah.
Is that it?
Yep. If node
How do
doesn't
I
have a
make a
trait.
how do I make a trait?
How to implement order trait in Rust.
How to implement traits in Rust? I think I people told me that is not as straightforward as in Haskell for some reason. Importing a trait. I don't want to
We
import.
can see the
Implementing a trait.
examples. We can see the examples.
Implementing a trait. So I you put the trait name with name.
No, no, no. That you are declaring a trait.
Oh, you're creating a trait.
Yeah. So look beneath, like no, 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 man. Implement with name for name.
No.
How do you see like the last one? We have a struct name. Oh my god, my voice is dying, man. Like struct name, and you have a string. Like read all
Oh,
this
here.
code, yeah, and look beneath
Oh,
that.
here. Okay, so okay, so it's too specific. I actually need to put how to implement ord trait. Okay.
Oh, that's nice. I think you only need
It
the.
has partial ordering.
No, no, no,
Interesting.
no, no. Wait, I guess that's.
No, no, I never explored. I already read about it, like partial ordering stuff that uses partial order, and it's its own deal,
Oh
right?
wait,
It's
saying that no, you yeah, we cannot
no,
do
here it
that.
is. So you have a person, right? So you have a struct of a person, and you're deriving the equal, which actually makes a lot of sense. I will derive that as well. How do I make a bunch of derives like this?
I would think so, but maybe you need like semicolon instead of colon.
It's common.
No, 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 semicolon. Yeah, I don't know. We need like
Oh
example.
no. Worst case scenario.
Oh no, no, derive and then you have the comma inside, like debug. Yeah,
No! You see what
nice.
happened?
Yeah.
It can't compare heap node with heap node. The trait partial equals are implemented. Okay, so it's not
Mm.
as smart as I wanted. Okay, okay. Let's copy paste this thing.
Yeah, it's
Oh,
pretty easy.
how do I know? How do I know which things I have?
Huh? Self
Oh,
dot something.
no, 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 no. I just want to know. For instance, there are two completely different traits. So you have the ORD and you have the partial ORD. You can
Okay.
implement the one and not the other.
Yeah, like the documentation tells you what you need for each functionality, I guess. Which traits do you need to implement?
ORD requires that the type also be partial ORD. Okay, so you do need to implement both,
Oh, okay.
which sucks. Uh, okay. So this is gonna be heap node.
Wait, probabilities? Oh, you want to
Uh,
order by probability.
okay, so what are those? Oh, this is the first self and this is the other self. You're comparing two
Yes.
instances.
Yes, that's pretty intuitive.
Whatever is this,
It's the type that you are returning, man.
we are returning a type ordering.
Yes?
Does that make sense?
Yes, it makes sense. Let me explain why. You have self dot the probability and then dot compare, right? Yeah, that's as easy. You are just comparing two floats, and the result of that is the ordering that is already implemented.
Now, why is this thing complaining still?
I guess your order is not right the way that.
Oh, you need it knows that the partial order is
Oh,
still not done. Some
yeah.
so no 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 no, but this is correct.
Yeah, I don't know about that. I don't know how that works.
So it's complaining about
Oh,
Can't compare hip node with hip node. The trait. Oh, you need partial equality as well. What the heck? Yeah, very, very.
that would be
I would
just.
say restricted. It's very restricted in
Uh,
comparison to
no,
Haskell.
probably that could be okay. Yeah, compared to Haskell, it could be. But I mean, those things they could be powerful, and we are not knowing yet.
No, I'm pretty sure they are powerful. I'm just saying that to have or sorting, you need equality. That's a restriction right there. Probability, whatever this is. Do I need to have? Okay,
Oh no, no, no,
let's.
that's wrong. Wait, maybe that's wrong. What does it mean to have partial equality? Because
I have absolute no clue, man.
don't you need to do and also check for the symbol if it's the same?
No, that would be total equality. I
Yeah,
think.
that's what I'm asking. What the fuck is partial equality?
No, I'm defining that a node is partially equal to some other node if their probability is equal,
And
and
why
their
you are
self.
using probability and not symbol? Like, what is the right?
Because the symbol kind of doesn't matter because they'll never be the same. Actually, if they are equal in terms of symbol, something is really wrong.
Okay,
Is this how we do end?
I guess so.
Okay.
But on the same line, I would.
Okay, let's save it, and it's gonna take a while to show the
Oh
errors.
no, not really. It's
Oh, yeah,
for.
it's wrong here.
Oh,
It's wrong
okay.
here. Okay, so it's complaining that. Oh, you actually need total equation as well. Holy Jesus! Oh man, this is so restricted.
That's
Okay,
quite a.
okay, let's see
Wait,
what.
wait. Are you really implementing the function name that you need because you copied and pasted partial weak? Like, take a look in the docs, man. You are implementing the function that we.
Oh yeah, you need to have partial, odd, and equal, which requires partial equal. Then you must define implementation for comp. You may find it useful to use comp on
Wait,
your
you
types
you
fields.
can derive equal, can't you? For partial from partial weak.
Let's try. So equal. Are you satisfied? Let's wait. No, it's not satisfied.
Hey, we have an error in probability.
The trait. Oh, that's interesting. It does not accept equality for floating points.
Oh, I see.
Whoa, how are we gonna do this, man?
Man, why does it need to have to be a float? Can't we use like absolute numbers? Can't we?
The only implementations are with integers, which makes a lot of sense because everybody that trusts equality or floating points, everybody that does this is silly, right? Because floating points are kind of dangerous matter. You should never trust equality on them. But we kind of need it because we're gonna use values from 0 to 1. We need floating points, and we need to make some comparison between them.
So you have to take a look on the net again.
How do you compare floating points? Um, how 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 do you compare floating points
In Rust.
in Rust? Comparing floats.
Hmm.
Uh, oh, okay, okay. So instead of doing this, we do this. Is that it? Self probability and then order probability.
I don't think the result of this is ordering, man.
Are you sure?
Well, the result should be their own type, right? If it's a mean, should return a float as a result.
Yeah, but it is returning a float. The
Man,
minimum out of these, no?
yeah, but you need the ordering. It's a sum type ordering.
What are you talking?
Ah, man, look at your signature.
Okay. So the comp function returns an ordering. Oh, okay.
Man, isn't that mean thing for defining equality? Like, if the mean is the max is the same, then is equal. Isn't that the case?
How can I do that?
Uh, I don't know. Maybe you would need to implement the trait equal for the f. Uh, or
Holy but Jesus, man. Okay.
why don't they have that?
Because floats do not satisfy the condition that for every float access. Yeah. This is a computer science. Uh, this is a related problem. Man, this would be so sad. They're weird because they can be not a
For
number.
example, using ordered float crate. Oh, okay. Maybe we have like libraries for.
Okay.
Looks promising that ordered.
Okay, comparing four. Okay, so let's search that. Ordered.
Oh no, take a look
Oh,
on the thing first, like the users.ruslang. Like maybe they have, oh, floating points number tricks. Open those two, man, on other tabs. Oh, those are the tricks, right?
okay, there's an assert.
Flip like a linter.
This is a really good suggestion. I'm surprised that some software made it.
Yeah, I don't.
Yeah, I think this is the article that my advisor told me to read.
Okay, send that on Discord. Yeah, I don't think we will have like what.
Mm, no, the article is basically explaining why we should never trust equality on
No,
floats.
I mean those floating point number tricks. Like, let's go out of this and go to the second
Uh,
one.
oh
And
man, that would be so sad if you don't have access to comparing floats.
why? Does that make sense?
I have no clue. You tell me.
I don't know about float representations, man. Not
Oh
really.
no. Oh man, that doesn't make any sense. Like I don't understand that for like real geo applications like planes and boats, not trusting floating point equality is like safer and things. But how the heck we can you can compare floats, man? That's like uh
Okay,
holy
so go to
Jesus.
ordered floats.
Okay, so let's do ordered floats rust. Wrappers for total order on floats.
Okay, we have struct. Look at the last one.
Ordered float. Oh no.
Right implement. Equal
How
order.
do I exactly like but
Use a
how does this
library.
work? No, but how does this work? I just put ordered in here? How does this work?
I
Okay, so there's a.
Wait, but you need to install that library, right?
You think so?
Yeah. Of course you need.
Hope not.
Of course you need. It's not the standard library, man. Go to crates.io.
Wait a second. I want to see the errors. Okay. Use or unsolved import. Yeah, so I do need to.
Go to
How
the
do I.
site crates.io.
Create.io.
Look at the name of the library.
Okay. That was unexpected. I
Oh no
didn't.
no no crates. Yeah, it's crates.
Oh, crates. Ordered float.
New order flow. So what
Oh
do you
man,
think?
16 days ago. What the?
Wait, why did? Wait, no, no. Go back, go back. Why is the new order the float updated over 3 years ago, while the old one? What the fuck? Okay, someone made a fork, but was not very successful. Okay, so there you have it. Like you can
How?
just copy that second line, just a second, and copy on your uh yeah, like below the dependency, and yeah, then you can just run or build cargo build, download, compile for you, dependency, yeah, that's it, and update the lock. Yeah,
Okay, so minor detail. Rust actually takes this whole comparison of floating point seriously, so
very seriously, huh? Very
we
serious.
can we can't compare them, and without comparing them, we can make probabilities and like sort probabilities. And oh man,
Holy, it's taking too long.
yeah, maybe it's downloading the world. I don't know. Maybe it's downloading the whole freaking world. 13 million, man. 13 million. Still going on, whatever it's doing.
Yeah, your network.
I don't know, man. I don't know if this should be the case. I'm starting to be doubtful
We
about.
can blame we.
We.
Doesn't make sense. Taking so long.
It doesn't make sense.
Yeah, like the
The thing that sucks is that we need to the. I think this is stopped working, right? So the if I save it, it's not gonna show the errors anymore. Oh,
what?
updating whatever this is.
Like you are fetching the registry. But man, all of that? Oh, I guess you have a bug on your terminal.
Oh,
Oh fuck, we are so fucking dumb.
that's better. Okay,
Yeah, we are
cannot find
just.
type F. Okay, so probably I want to do F64.
Man, look at the documentation. Are you sure that's the case? Wait, you had the documentation open, man. See the API yeah.
Oh, here.
Oh, okay.
Yeah, so it's the way that I'm doing, but it's not working. Oh no, it's accepted. It accepted F64, which is okay. Now we need to understand a way to make the comparison. How we can compare them.
Just go back to where we were before.
Oh, Uh,
we can just write. There we are able to.
because I already forgot. And
But I know like itself dot.
okay, so it's self.
Oops, you have us
No,
like
but wait. Now that this is so ordered, shouldn't we be able to derive it?
no, but you are implementing order heap node. Man, you are
Wait.
implementing ord for heap node.
No, that I got. Okay, you're correct. Uh, okay. So here's gonna be a self probability
Yeah.
compare, and then I think the other probability or something like that. Are you happy now? No, because I need
Oh,
to delete this. Are you happy now? Let's wait. Wait a little bit. It worked.
what is the problem? That is just unused.
Yeah, unused stuff. Okay, so we this okay, so it's pretty similar to type
Yeah,
classes.
but can you explain me the partial order?
Um, the, man, I already heard of it when I was doing my graduation project. There's something called partial ordering.
Wait. It's basically like some things you can sort, some things you don't, and if you can, then return some. If you can't, just return none. Is that it, right?
It's related to that.
Like
Okay,
the way that you read wrote
a
on Rust code.
a partially ordered set formalizes and generates the intuitive concept of an ordering, sequencing, or arrangement of the elements of a set. A poset consists of a set together with a binary relation.
Nah, that is not meaning anything to me.
No. What you need to okay, so I'm gonna translate it. Basically, it's saying that a partially ordered set generates an intuitive concept of
No.
these three
Lemos,
operations.
just read the phrase of the next paragraph. Like it says everything.
The word partial in the name's partial order or partially ordered set is used as an indication that not every pair of elements needs to be comparable. That is, that may be pairs of elements for which neither element precedes the order in the poset.
So that would be
Partial
the
orders,
non case.
yeah, and the counterpart for this is total orders.
All of those could be like order, right? Well,
Yeah.
compared.
Oh, and this makes a lot of sense because of the not a number, right? Oh, makes sense.
Oh, we don't. Oh, fuck, that's nice. Because we don't
Uh,
know, right? Like if they are like less or more
okay,
than.
okay, okay,
Okay,
makes sense.
let's go to our Rust.
Okay, um, now that we have a binary heap of heap nodes, what I want to do,
Even
I want
though
to,
you are not sure, right, about this partially equal, partially.
yeah, I'm not sure. I'm not sure. That's just a guess. But I want to do this thing, heap dot push. I want to know what happens. So if I do a heap, if I do this, and instead of reverse, I do, how do I create a record? Do you know that?
I don't.
How do I create a struct?
I don't
How
know,
to
but I would bet
instantiate?
would be like the name of the type, column, new, and passing the argument. But I'm
Oh,
not
it's
sure.
exactly like in Haskell. Okay, thanks.
Oh, okay.
uh, okay, so this is gonna be a heap node. Yeah. Um, the probability. In this particular case, let's do, I don't know, 0.5, and the symbol. The symbol is like a char, so let's do like, I don't know, A. And this is gonna be, I don't know, node 1. And we can pick all of that and create like the node 2, in which we have 0.4, and it's gonna be, I don't know, K. And then I want to push. I want to push node 1. Actually, I want to push node 2 and then node 1. And then I want to return heap. Um,
I'm
and I
taking a look on the
think
partial equalities.
okay. No, but I read about it because some of the mm, like related stuff to continuous time, they talk about partial order and total order and stuff like that. Okay, so how do we do the types of? Oh, it's like this. Okay, so you want to do something like this, but not exactly.
Uh, well,
Binary.
let's do a total equality, or partial equality. Uh, so just change like the symbol for an equal, right? Oh wait, but what the fuck? You are actually is that okay? Like you are comparing the probabilities of all this after all this thing, you are just comparing normally to probability. What the fuck?
We can do total order and make both of them be equal.
Yeah, but what I mean is, why can't you just like probably equal? Why can you? Is because you implemented the equal, or you could do that already?
I don't quite see what. I don't quite see your question. The thing first, this is wrong. This should be older. Second, I just defined an arbitrary. I
No,
don't
no,
know
no. I mean,
criteria.
probability is a float, right?
Probabilities of float.
So
Yes.
you have self dot probability equals to other probability. Would that be a problem? Comparing those?
Oh, this is wrong. Order. Uh, I see what you mean. That we are comparing. We are actually crossing the line of like being reasonable, and we are actually comparing two floating point numbers. But this is not a problem for our application because like it's this is so unlikely to happen ever because of how the nature of human language.
Wait. But can you do, because probability is not a float anymore, right?
Oh yeah,
So can you do like dot equal in self dot probability?
good question. Like I'm kind of missing my Emacs shortcuts.
Wow.
Oh yeah,
Okay, yeah, let's go with that.
still complaining though. Let's
Is
save it.
it a reference? Yeah,
Wait.
it's a reference.
Okay, so oh, I reference. Okay, so I need this. Okay, okay. Um, good to know. Okay, so I can't. Okay, so this is not C, so I can do
Oh
this for
wait, you
charts.
can do something. Yeah, B before the literal.
Ordered float. Okay, is this what you want? Oh yeah. Okay, now we can just do I don't
Or
know.
like
No. I don't want.
or
I don't want to. I don't want to see that yet. Let mute. Let's call these probabilities for now. Just for now. I just want to see if the heap property is being followed.
yeah, but
Uh,
you will print that, right?
yeah. So calculate probability. So we have a heap like this. Calculate probability, and then we pass the file content, and then we're gonna do the exact same whatever the heck that is that I still
Wait,
don't know.
but you will try to print the heap?
Yeah.
I don't think that will work. Let's try it. Wait, we are
Right? You
having a
think?
problem with the file.
Oh yeah. So it's complaining that this is private, which means that this needs to
Oh,
be pub.
okay.
Okay. Next error. Now it's complaining that we're expecting this to be
Oh,
mutable, like this.
no, no, but a reference. Well, mutable reference.
Is this what you want? No.
Oh,
Type heap node
oh,
is
okay. Yeah,
private.
yeah. What you do is go there on main. Yeah, and then after the heap, you would do like colon colon, and then between curly brackets, the name of the type.
Okay, so heap node.
I guess that.
Heap node. And I also think I need the binary heap there, if I'm not mistaken.
Um, this not work. Oh, I guess you can
Still
also remove
complaining?
the curly bracket. Not sure.
Still complaining though.
Maybe the mod doesn't have that thing. Oh, maybe you need to put public on your type.
Oh yeah?
Yeah, but
On a
then
struct
yeah, I guess
like
so.
this?
Hmm? And then maybe you can like remove
Hmm.
the thing that I.
Okay, interesting. So by default, everything is private.
What is the best default, right?
Eh.
No, no, it's the best fucking default, man. Don't even start.
Don't even
Like,
start.
what do you mean that things should be public by default? That's messy.
This is not objective oriented, my man. So I don't know what you're talking about. Is this it?
You're not using binary here.
But here you're saying that we're not. Oh, you're not using the buffer yes yet. We're not. Okay. So can we see some action? Hmm.
Holy, it's actually. Oh, is this the debug? Try to remove the debug. Let's see if that's the case.
Okay.
Oh, that would be nice.
Okay, I'm just deriving whatever this is.
Yo, paradas.
Hey guys.
Uh, your mic is really strange for some reason.
Oh,
Oh yeah.
really?
Yeah,
Is it better now?
go to user settings, voice and video, and try to mark the noise reduction thing.
Okay, sure.
Oh, we kind of need debug to print it. Interesting.
Oh, okay.
So it was a good idea to print this whatever. Okay.
Yeah. By the way, why are we deriving equal? Oh,
I have
okay,
no
okay.
clue.
No.
We can derive because of partial equality, right?
Yeah. Much better, Paradas.
Nice. Okay.
Okay, so what I wanted to test again, I wanted to test if to see if the hip is following its property. Oh, it is. Nice.
Yeah, but before that, can you like uh go in with an overview like on what we
Yeah,
are
of
doing
course.
and on the code for Paradas?
Okay, so Paradas, if you go to the project, the channel on Discord, you're gonna see that I provided the link so you can program with me in like uh,
Nice.
with two courses and whatever. And I was explaining to Nathan that what we want to do is basically to make the most frequent bytes be represented with less bits, right? So instead of using like 8 bits for a byte, we
Yeah,
want
yeah.
to make it like represent the most frequent ones with less than 8 bits. And we are
Yeah.
at the point we right now we already know how to read a file. So we made a way to read a file in Rust, and now we are making the data structure to calculate the probabilities and sort them from the greatest to the lowest.
Oh, nice.
And
That's
then
something
Nathan
to.
explained to me that this is what it's called traits in Rust, the type class system.
Yeah.
Uh, and we are making, and why we are using a heap, right? So why we are using the heap data structure is because we want it to be naturally sorted, right? We don't want to have to sort this thing again. We are adding things onto the heap, and the heap itself is naturally sorting itself,
Yeah,
which
it
is pretty
makes
nice.
sense.
uh, okay, so now that I know that this is working, I can just delete this. And now, Nathan, what we need to do is the following. We need to do a for.
Wait, Lemus. You saw? Was it? I think it was an array, right? The implementation, because it was printing as a array, I guess.
Oh, you're talking this.
Yeah.
No, no, no. Probably the implementation behind the hood, like low-level implementation, is probably an array, but that doesn't matter because it's abstracted out for us. So we can
Okay.
just treat it as a tree, and it will work as a tree.
Yeah, but what I mean is, it's using that representation, so
Oh
that's
yeah.
cool.
Okay, so what we want to do now is to calculate the probability. So what we need to do is first things first is to get the total amount of elements. By the way, Paradas, if you try to enter the live section in Visual Studio Code and doesn't work, please tell me.
Okay,
Total.
sure.
Okay, so what we need is a function that picks a vector in
No, 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 no,
length
no,
of
no.
a vector.
That's just dot length.
Oh yeah.
Yeah, but
Yeah, that really works.
yeah, but that is a thing. I'm not sure if you would prefer that or receive another argument like in C with the U size. Because
No, we don't want that.
no, 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 no.
No, I
Wait,
like it like, yeah.
wait. It depends, man. Because I'm not sure if it's the same information. You should at least print both and
No,
see if
it
it's
is
the
the
same
same
number.
information.
No,
We
no, no, no.
These numbers should never be misaligned,
No,
right?
yeah, no, no. But what I mean is, go to the main, and there you have like, is it on read file? Where is the return of read file?
I think it's a result. No, it's
No, no, don't try to guess it. Just
yeah, it's a result.
yeah, a result of U size. Print that U size for us to see if it's the same one that you get inside there.
Okay, so let elements. We can try to print ln, whatever this is.
And
Does
if
this work?
no, I don't think so.
Really?
I don't think so, but might
I
be
don't think
thing.
so. Yeah, you should use the other one.
Okay, that's sad.
Not really.
That's
No,
really
no, no,
sad.
no.
That's
We
really
don't.
sad.
You don't need those. Only when you
Yeah.
cannot. Only when you don't have the display. No, man. You need a string. I guess that always. But the placeholder is the normal one. Only curly brackets.
Oh, like this.
Yes. And write
Yeah.
something so we can see like. Oh no, the order also tells us.
Mm, okay. Is this what you wanted?
Yeah,
Okay,
but
so the
are you?
placeholder is basically no, it's basically open and closing braces. Okay,
Yes. But
weird.
hey, that's one U size. Now you need to print the len. This total that you have.
Um, total.
No, no,
This
no,
will
no, no,
be
no, no,
your
no,
side.
no,
No,
no.
but we don't have to call this again because it's already being provided to us here.
No, Lemus. That's the thing that I want you know. I want to know if the dot
Learning on the
len
test.
will give you the same as that one that you have on main. Because if it's the same, then you can choose. If it's not, then we need to see what is the problem.
We can do that. No problem. Um, just passing a random number here just for. Okay. So if you do cargo run,
But you are not printing the dot len inside.
Yeah.
12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Oh, okay. The dot len would be the yeah. Okay.
Yeah. Okay, so these will be elements. Actually, total number, right? So
Number of
total
elements. I don't
I
number
know.
don't
of.
think you need to pass them. I think the
I
better
would
practice here would
prefer
be not
that
passing it.
performance wise.
Yeah, it's
Because
just performance wise because we're gonna try
Okay,
to do
okay.
this
Yeah,
with
it makes
this.
sense. Okay, yeah. It makes
Um,
sense.
um, and again, by the way, if you want to help me coding, like I went to code because this is fun because I never programmed in this before. Uh, okay, so it's complaining already, which is not as it's because it doesn't have a name number. Okay, so what we want to do is basically do a four byte in buffer.
yeah, I guess you need to invoke like dot ether in
Um,
yeah dot ether.
Yeah. But
where
into ether.
buffer?
Into ether.
No, no,
Yeah.
no, 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 no,
No.
no. For x in something dot ether, and then call the
Buffer dot. Why do you
ether
need to do that?
because it needs to.
Oh, that's a. I didn't like that. That
Because
doesn't make any.
ether is a
Returning
byte
a
class object.
iterator, right?
Is a,
And what you?
yeah.
Yeah, but this is just a bad marriage between C++ and Python.
No, no,
This.
no, 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 no. You are not getting the meaning of it, man. Like on int, like on in something, it needs to be a iterable, and it's probably not by default, right?
Yeah, exactly.
Still don't get it. Like this is basically C++ in the Python
No,
look.
no, no. You are looking at the fucking syntax, man. Look on
No,
what
no,
it
not
means.
syntax. I'm just saying that. Why not this? Give me a reasonable explanation to not do
Because
this.
it's not an
Because
iterator.
buffer, yeah, exactly. Buffer is not an iterator. For in is basically a sugar syntax for buffer dot for iterator dot for each, I guess.
Yeah, so it's exactly what I said. This is what you just said, Prad.
Yeah,
This is
but
basically the same
buffer is
explanation
a
of C++.
vector. No, yeah, but buffer is not a vector. Buffer is not an iterator; it's a vector. So you have to turn it into an
No,
iterator.
yeah, but that's exactly the same thing that we need to. That's exactly the same explanation in C++. Anyway,
Okay. So you would like more sugar in it.
I would say that I would not mind.
Yeah, but
Like,
Oh, and by the way, it's not Python, so I guess you need
no, no, no.
to.
But this for whatever in
No, no, no.
this
That's
is
not.
very
That's
fine.
not it. The column. I guess you need like a block, and not the column.
yeah,
But I
Oh,
could be wrong.
oh, you need like braces like this.
Yeah, but with
Oh,
space.
oh, like this space like this.
Sure.
yeah.
Okay. Okay, so we want to push. What do you actually want to push? You want to first make a node, so let node, and this node I will be reusing, so it's mutable.
Uh,
Uh, Here, and then we're gonna do like this, and then we want to have probability.
battery.
Um,
Oh wait, your insert.
oh,
Your insert will not work.
oh, but that's oh man, the only way to do this in one single in one single cycle is to do the continuation passing style, Nathan.
What do you mean?
Because we need to accumulate all the repetitions that a certain symbol has.
Yeah, I know that you have to accumulate, but I'm not seeing your conclusion that you just.
No, because this is exactly what you did two times now, right? When you demonstrated to me the continuation passes time is when you have to do two loops,
But not
but you
be.
want to do you only one.
No, 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 no. Was not because I needed. Was because I could.
Oh, you can't do this here then. Okay.
No, no. I
Um.
guess you also can, but you shouldn't because, well, I guess you should avoid recursion in Rust. Not guaranteed as one would like. Mm.
Um.
But hey, hey, let me see.
Let me just think a little bit how I did this back in the day. Uh. How do I did this
Yeah, don't the heap
here?
receive some kind of thing to say that it's to update?
Okay, so when I did it, oh, I see what I did. Okay, so in this line, I am shrinking the file, the content, to only to the unique symbols. So this I'm using the abstraction like set, and a set in mathematics is a without repetition. So
Okay,
this is
only unique ones. Okay.
only unique. And then for each element in this set, I am counting how many of them happen in the original content,
Ah.
and then I'm dividing it by the total. This is the way that I'm doing it.
Okay.
So this is still a two loop, right? So this is definitely one loop here and then one loop here.
Yeah.
But are we actually like with the intention of doing this in one single loop?
I
How are
don't.
we gonna do that without continuation passing style?
Man, first of all, just forget
I think you
about.
should use the same strategy.
Yeah, I agree. I think you should do the same as you did in Python.
Mm. Okay, so how casting in Rust works?
Casting?
Yeah.
It doesn't have casting. I don't.
Set
Let's figure it out.
Oh no
latest
no, we saw that has like on
Yeah,
the.
it does has.
I guess we saw on that same.
Rust.
But wait, man,
Another collections.
why the fuck is that your first solution? Casting for what exactly?
Because this is what we're not gonna need to do. Because here we have a vector.
No 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 no. Probably what you want is set new, and then you pass something. Then it has overloads on what you turn something in a set, and on the
Yeah,
process on getting. Yeah, that's not casting, man.
this is casting.
No, it's not casting.
This is casting in
No,
low-level programming languages. So
no, 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 no,
casting
no, no. That's not casting.
programming languages.
Casting would be in C. You annotate with int first. That's basically you
Yeah,
passing a type to new, and then he's constructing a new type for you. That's not casting.
look in the project part. I'll send a way to do it. You have to turn it into a hash
I
set
think that
this way.
What Nathan is saying is basically like a fancy way of not. He doesn't want to say casting,
No, no, no.
with
It's
all the terms.
no, no, no. Actually, it's not casting, Liam. Casting would be okay. Let's get the
Yeah,
same.
you are passing the data to other structure.
Yeah, and just like
This is not
changing
a
a
cat.
tag, right? To say that is other type.
Yeah,
Is this
exactly.
function? No, wait.
Wait. Hash
Wait, just a second. I think that we want this.
from.
Um, I don't know.
Yeah.
Let.
Wait. Can't we do like the hash set from no, from probably not, right? From rib. Yeah, probably not.
What we want is
Previous
like
buffer.
buffer.
Oh no no, we have a vector, right? Oh.
Also, the same problem that I went into with in Python. I need to clone it. That also happened there.
But hey, can't we do like hash set from vector? Vector is.
No, you need to turn into an iterator.
Oh, okay.
Which it's kind of bad.
That's fair. It's
But
more generic.
Yeah,
unique elements. Then for every element in this thing, we go. This is a hash. Do I need to transform this hash set into an iterator again?
Sure.
yep.
Okay.
But hey, how does he knows? Like, how does he knows how to insert properly in a hash set? Like, because
So
it
I
has
don't
to
know how
know.
it
Okay,
runs.
that's the same symbol. Then I will update the number of. Oh no no. Oh okay okay okay. He is just comparing. Uh.
You probably only get the unique. Like if it's already there, he
Wait.
doesn't
What
have
is
it anywhere.
buffer? What is buffer again?
Buffer is the
The file.
yeah
Oh, it's a
buffer dot.
vector.
How do I count things on a vector? How to count in vector?
Lemus, if we are using this hash set, I don't think we need a heap, man.
Dot count. v.iter.count.
Can you repeat that again? Not
V
count. You said
Can't we use
count
directly?
the hash set. No.
No, no, no. The buffer, like you are. doing buffer.iter. See if you can already do the count without the iter.
I couldn't. I tried.
Oh, you tried?
Yeah, count.
Or
See?
len? And what about the len?
No, the len will just pick the total number of elements.
And
We don't want that. We want to count how many elements we have of a certain, like this, actually.
Oh wait,
oh,
you have to filter it.
Oh
Oh,
yeah. Okay, more functional then, at least. So filter.
that
We don't
no, you
have
need to
ether,
iter first,
and then
not
filter.
filter.
yeah, it's kind of funny the
Filter map.
anonymous function.
No, I think only filter.
Uh,
Only filter. Only filter. You
no,
need
yeah,
to
only
filter
filter.
the ones
Only
that are
filter.
equal the elements.
Okay, so how do I do anonymous functions in this thing?
Yeah, it's quite
Uh,
funny. Pipe.
yeah, yeah. Pipe.
Type.
No,
Oh,
Yeah,
pipe.
pipe like this.
No,
yeah. No, no,
no,
no.
pipe from
Just the straight
Unix.
bash. Yeah, another one.
Oh, like this.
Yeah, then you
Yeah,
have the
but in the
argument
middle of
between.
it.
Like
Yeah.
this.
No, no, in the middle of the pipes.
In the middle of the pipes.
Yeah, you
So
put
like
the
Yeah,
this.
X, yeah, and then you only
yeah,
have like space and then body after
yeah.
the
Exactly. You don't
the
need
second
the,
the arrow.
the
Like this.
Yeah, I guess
yeah,
so.
And then is equality like this?
yeah,
I don't know.
yeah. It
Element.
is. But
Holy but Jesus. What the
I
heck
don't
is
think.
this?
Look, I do think you need to pass the. You need to pass it like as a pointer.
What?
Look,
It has partial application, this thing?
I'm not sure.
I'm
Oh
not sure also.
no.
I
But
wouldn't.
I think
I would not. I would not think that. Not by default, at least. Not auto-curring, right?
we should do it like that. Uh, let me see here.
Okay, okay, but then why do we need the can you explain to me the syntax because this is so weird. So what is the this? What is this? And what
Man,
is this?
it's the argument. Oh, okay. That's
Yeah.
C.
So you're pass. Yeah, exactly. You're passing a pointer to the element, and then
Okay.
you are getting the value.
Differentiating it.
Yeah,
That's
exactly.
Yeah.
tricky to say, but yeah.
Holy budgies, that this is a filter with C in the middle.
Yeah.
But
And then
Okay.
safe.
you need to
But
count.
safe.
But you need to count. Yeah, and you need to count after that.
uh, no, this is land now.
Ah,
Land.
it can be len. I think
Um,
count and len are the same function, though. I don't know.
Oh.
are you sure we don't need parentheses in this thing?
Yep.
Man, you just fucking love parentheses, don't
No,
you?
I don't. But I'm just
No, no,
like
you don't need that.
Yeah, pretty sure.
pretty
You
sure.
don't need it.
I
Yep.
Okay.
guess that if you save, he will even delete your.
Okay.
Yeah,
Let's see
now
what.
look.
Okay. Okay. And now we need the symbol itself.
Wait,
So it's gonna be a
why is
symbol.
your heap node is not? Oh, okay. Now you have the
Element.
symbol.
It's not mutable anymore, also. I
No,
don't
it
think you
will
need
be because I
the.
will reuse this.
Wait, but the
I don't
symbol
think you
should
need
not be.
the dot com over there.
Sorry.
The first line on
Okay,
the.
here.
Oh, okay.
Yeah,
Oh, it's common. Yes.
yeah.
Okay, so let's save it because this thing only fixes itself when we save.
Oh, whoa,
There's
let.
no way.
No, no, let. You need a termination. You are using let.
Oh, here. Okay, so let's see.
Oh, man, remove. Hey,
Elements too bad.
hey.
What's the problem?
Remove that return, man. What the fuck?
Mm,
And then the other element you probably need
yeah.
to repeat.
Okay, so there's
And I don't think it's len. I think it's count maybe, but let's wait. No, len works.
man. This is a really no. This is still complaining though.
Yeah, it's count. It's count.
Yeah, no, but it's complaining. I think the parentheses would also solve this, but okay.
No, I don't think so. Yeah,
Because it's
maybe.
complaining
Maybe.
that filter doesn't have len. But I don't want to do a filter with I don't want to do a len with the filter, right? I want to do a len with the result of buffer.iter.filter. And now it's complaining about type
You're
conversion.
casting it. Yeah, you're casting it to float.
I need.
So now, no, but now I do think you need to cast the other, like the count number to float.
Oh, you prefer casting this to float, the first. Is that it?
What is float?
Wait, let me see the error message
No, the
again.
error is this is a U size and this is a float.
Okay.
Wait, how does it count a float?
No, it's not a
No,
count
no,
because this is a vector.
expected. No, no, probability is expecting a float, and we
Yeah.
are passing the U size.
No, we are, but that's the thing. This is U size. There's a division here in the middle, so we are picking something that is a float
No, no,
because this is,
no, no. Count shouldn't be a float, man.
but it is.
No, count is
No,
not
no,
a
no.
float.
Lemos. You see
Oh, I see, I see, I
ordered
see.
float.
It's the final result of this, right? The final result
Yeah.
should be a float, but it's a U size.
Yeah, so
Okay.
we need to use other division. That's integer division, right?
Yeah, exactly. The division is the problem.
How? Which divisions we have available? Division,
Maybe
float,
float dot. I don't know.
integer division, fraction division.
Oh,
What the heck is
define.
that?
Oh, you can just cast total to float, and then we'll get the
How do we
division
do
No,
result.
no, no, no,
casting?
no. Don't cast. Wait.
No, as a total as for 64.
Uh, okay, let me see.
No, no, not dot s, space s. You don't need
uh,
the dot.
Oh,
S?
Uh-huh.
do you
Like
need
this?
do you
Yeah,
need parentheses?
F64. Probably. I don't know. Let's
Holy.
see.
Yeah, I would. What the
No, you don't.
what the
Oh,
Yeah.
fuck?
it worked! It
Yeah.
worked! No, it didn't work. It did parentheses.
Also,
Oh,
do the
so
same
cast the
with the
first
other.
one. Cast the
Yeah.
first one. No, but I think if you cast the first one, you don't need to cast the second one.
I would not like if you only need to cast one. Yeah,
No,
No, no, it
I
didn't
think
work. It didn't work. It didn't
yeah,
work.
but I think you just need to cast one because if you have one float, this is a float division.
I would not like that, man. Not at all.
Why not, man? It's the same thing.
Okay, so it's
Wait,
complaining
we
now
have a
about this
problem
guy.
here. Man, it's on the.
Type annotations needed. Okay, so it's requesting a type annotation for this guy, which is fine. So this is gonna be a hash
Back.
set of U8, comma, and a number, right? So do we have integers in this thing?
Yeah, but not this way. Like use something. You a number.
Yeah, you wait probably again.
U32.
Why are you using 32 again?
Is yeah, because I'm a C guy and C is 32 bits.
Okay.
Uh,
No. It can be 32 bit.
no. If you do int in C,
No.
if
You don't
if you're using
know.
the standard, no,
I think you
if
should
you're
use
using the
you
standard
wait again.
compiler is so,
No. You
which
don't
one?
know. It depends on the machine, man.
No, yeah,
Yeah.
depends on the machine. But if you're not talking about microcontrollers, it's like 99% chance it's 32 bits,
Yeah.
I think you should use you wait again.
like this.
Yeah.
I don't think U8 is enough. I don't think U8 is enough.
Maybe right.
Yeah, I
Yeah,
would
maybe
use
right.
a bigger one just to
I
guarantee.
think I think that at least 32, man. Look at this text. Like, are you sure we're not gonna?
No, that's the different kinds of thing, right? Of
Yeah, this is the no. This is the total amount of repetition.
wait, that
Yeah,
one that you
exactly.
have
This is
there?
the symbol. This is the symbol, and this is how many times it repeats itself.
Oh, okay. And you can go. Do we have big int in Rust like on the standard library?
Good question.
Okay.
If you guys don't know, imagine me.
Is it that though? Oh, look at it. Look at it again. Why is it giving us errors?
Okay, it's saying that the trait bound U32 build hash is not satisfied because
Oh, what the
of the
fuck is a
requirements.
what the fuck is
Mm.
a build hasher?
Now go up there. Go. Take a look again at what is the hash set. Only the hash set.
Random state. Okay. Not
Guys,
sure.
I think I will have to go, man. We are like already past the time.
Okay.
Yeah, just finish the recording and we are done, I think. Yeah, but I still don't get why this is not.
I
Do you
don't
have any
think it is
idea,
in
Parato?
int32 there though.
Well, I think he's saying that we don't have a trait, but why do we need that trait? I don't know.
No, but
I don't think it
even
is in
even worse than
int32
that,
there.
even worse than that, because if you remove the type annotation,
It goes on
it
there.
will move. If it will say that you need a type annotation. That's what is triggering me.
No, no, and that's okay. The type annotation was working,
Type
but
annotations needed for this cannot infer type for the parameter as declared in the struct hash set.
yes, and he was right. Like, uh,
Uh,
he was accepting your type annotation. He was just complaining that the type that you annotated doesn't have certain trait.
But what is exactly the parameter asking?
no, man. I'm.
What does it
Wait
mean?
a second. Wait a second. Does this make any sense? Because when I did the original version, I discarded the counting, right? So this set is only like an array of numbers, unique numbers. Why the heck this is a tuple? Why the heck we have
Exactly.
unknown? Yeah,
That's
this is
what
Man,
not right.
that's
man,
what
This
I'm
is
trying
not
to
right.
understand.
I think that hash set is not what we want, man.
Oh. Oh, wait, that's possible. That's possible. So we don't want a hash
Yeah.
set.
Maybe, yeah,
So
just a set.
set in Rust. Yeah, but that's the first thing that appears in
Yeah, it
this
doesn't mean
thing.
that's the only one that exists.
I'm not also saying I'm not saying that.
So what about trying just set? Like the same way that we
Oh,
imported
hash
the hash
set
set?
from. Hash set from. Hmm.
Oh,
Could we try
Yeah,
that?
sure.
and then he gets it?
No, wait, because the errors will come. I know. Okay, now it's problem with the cloned.
What is the problem?
Let's try to not use the cloned. Just to be sure that this is okay. So it's
Wait,
still
wait, but
complaining.
the cloned would be the same exact typing.
No, it will be the same exact type, but is
Oh,
the trait bound to hash set is not
uh,
satisfied. But what
wait,
the
Lemons,
heck?
Lemons, go to the top of your file.
Go to the top of my file.
Yes,
Oh,
this hash set, change that for a set, man.
like this?
No, I don't think it has a set.
No, I think it's
I
exactly this, isn't it? Isn't this what we want? We wanted to make a hash set of this of an a list or array or whatever.
Like, what would, why would we need the hash set? Like, just want to have,
but it's not a known list of items, I guess.
man,
That's the
don't you have
problem.
like a vector dot unique? That would simplify a lot, even if it's not the,
Um,
yeah, maybe we do.
no. Okay, so
Okay,
there's
ether,
ether.
try unique.
Unique.
Unzip.
Oh, man,
No.
see on Google, like, unique, have a bunch of,
There's a fold. Inspect into is empty is sorted last land map. Next partial position. There's a reduce. There's a bunch of another fold in here. Um,
Oh,
unzip zip.
you need to use ether tools. Ether tools. Look,
wait, is that Python?
Is that
that
Python?
looks like
Okay, so get unique members of vector Rust. Better way to find unique values. Oh no, this seems bad. This is a map. Um, Look at this crap just to make a unique.
Oh, and they are using hashtags. Oh fuck.
Look at the one that I sent you.
uh, iter tools. Okay, let's try that. I just want to see the probabilities, and then we're done. You can go, Nathan, if you want.
It's because I have to record, right?
No, no, no. We don't have to record everything. Like it's just like it's just it would be nice. I'm not saying that we have to. Um, iter into iter unique collect assert. Oh, I see. Okay,
Into
so you're
ether?
suggesting to do this and then this, but instead of v, we use buffer. Is that you satisfied? Wait,
Yes.
no. No method name unique found for struct slice it or mute in the current scope. What the
Oh
heck?
man, maybe you
Okay,
don't
so
have data tools.
no. Oh, that's possible. That's possible. How? Oh, that's totally a thing. So how do I do this again? I already forgot.
Cargo,
Iter
yeah, Peter
tools.
tool.
Which version?
Let me see.
So iter tools Rust.
Man, don't they have a
I
library in
think you have
Python?
maybe a cargo ad. Our cargo ad. Peter tool. Let me see.
Okay, let's try that. So remove this.
Ah,
Not cargo
Cargo
ad.
wait, dash dash out.
0.10.2 the version. 0.10.2.
zero
10.2.
zero
Yeah,
dot
I
what?
guess that you only have
10.
like.
Oh no. Yeah.
Okay, now we need to do the cargo build.
Cargo build.
Yeah, I guess you can only do like cargo install, but that's to install binaries, right?
Yeah.
And you can do the update, but it's to update the pack the lock thing.
Oh,
Okay, now it should be something there. Okay, let's see
okay.
the collect is not working.
Now it's complaining about the.
Oh,
Oh, it probably is not for mutable crap then. No, wait. No, wait. Still wrong. Still wrong. Okay. The trait bound for mutable you wait is unsatisfied. The following implementations were found. Okay, so it appears not accept uh, mutable things,
Yeah, it
which
makes
sucks.
sense. Not a sec. Yeah,
Okay,
you have to
how
figure out
can
that
we
code.
make something mutable unmutable, Nathan?
ah.
You can't.
Immutable, right?
I guess you can just declare a new variable and assign it. Let's try.
Okay, so let immute.
Oh, wait,
Um,
wait, wait,
un,
wait,
un,
wait, wait,
Oh
wait.
wait, you probably need to
Try,
dot
try
clone.
cloning it. Try cloning. Yeah, try
Yeah.
cloning.
Because
okay, so clone.
Lemos, let me explain. The way they do it is when you do let something equals to something, if that thing
Oh,
that you are attributing, it implements a certain trait, then it only clones. If not, you are borrowing. Passing a
Unique
reference.
elements
yeah, it's the same thing with
specify.
Python.
This is
It's the
a
same thing,
vector.
exact same thing as with Python.
Unique
I need
elements
to
is
specify
just
here.
specify. Yeah, vector
Vec
of the.
u8.
Let's see if it
Okay, let's wait
works.
because
Yeah,
Oh,
nice.
okay.
oh, that's promising.
Variable does not need to be mutable, but it needs to be mutable.
Oh,
Because
because you
at each
want to
iteration
like.
of the loop, I am redeclaring with the new thing.
No, you are creating a new one.
Yeah, you are just.
Okay.
Is it
Okay.
because you want to change that later inside the?
No, it's because I'm using the same name and I'm
Oh
overriding
yeah,
it.
that's not a problem.
Okay.
Yeah, you are
Okay.
shading. It's fine because inside this is one of the nicest thing about Rust. When you go out of the for loop, it loses the like it's
Okay.
memory
So
borrowing,
But
okay.
so it
So
loses the
but
references.
folks,
let's
that's also for C, like the same thing.
Yeah, C also works, but C rewrites it, I guess.
let's count. Okay. Anyone has have a calculator?
I have a cell phone.
Okay.
What
Let's count.
what do you want to know?
Uh, I want 5 divided by 9, 12.
Nine.
12.
I
5 slash 12.
wait a bit. I don't know how to use a calculator. So 5,
5 divided by 12.
5.
I think it's correct.
Oh
Oh,
no.
that's 0.4166667.
Nice.
Holy
Yeah,
fuck, that's nice.
yeah. The other two are correct,
And
so
now
that's why
4
I counted.
divided by 12 is 1/3, and this is
Yeah,
exactly 0.333. And then we also have
3 by
uh,
12 and
one
half.
fourth, and that is 25%.
Alright.
It's
Nice.
correct.
Okay, so
We
let's
got
just
it.
remove these warnings, and I will commit this. And then, if you want to work offline, Parados, because you was a little late, you can do that if you want.
uh,
Okay, nice.
Folks, like maybe next year we'll be doing some. What is the name of the project, man? In Rust, that game?
Game Cube World.
No, no, no. It's not Cube World.
I want to make a Cube World game, man.
No, no. You could. Yeah, or you can do that. But I forgot. I totally forgot the name. Let me. Rust voxel game.
What about the logo,
Valorant.
Parados?
Valorant. We could
Oh,
be.
Valorant is in Rust?
No, 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 no. Everyone understands Valorant. It's not
Oh,
Valorant.
okay.
It's Valorant
Oh, okay, okay.
Valorant. Okay.
with an E, not an A, and not a T on the.
So, Parados, what about the logo, man?
That's a good question. I
Oh,
didn't talk to the guy yet. I'll talk today, probably.
Lemus, do me a favor, man. Yeah, like inside of VS Code. Oh wait, uh, man, you are replacing your your. Oh fuck, that's bad. Yeah, the
Mm,
LF is the termination of a new line for Windows, right? Well, for Linux, the LF.
no, but I am inside that WSL, so I think it's
No,
fine.
no, no. You see, like in your VS Code, you have the correct
Yeah,
one.
this will be fine.
But inside your terminal, you converted those somewhere.
I
Like
want to
see,
know why this is happening, though.
no, no, go up a bit. See, like when you add, that happens.
Oh, okay,
That's
that makes
bad.
sense. Yeah, yeah, but help me to fix this. I'm not getting why this is happening.
Have you like created on
Minus
GitHub and
you.
cloned?
Yeah, this is on track it probably. Just
Like,
minus
do you have a
you, I think
GitHub
it's weird.
repository for that?
Yeah, of course.
And did you clone it? No, you didn't.
No, I didn't clone it, but I picked the
So
SSSH,
No,
you
whatever.
no.
need to put git push
Yeah.
minus u origin master.
He sets the origin
And
while
this is
pushing,
probably
right?
main also. Yeah, and this is probably main, not master also.
No, but this is not what we are doing, dudes.
No, 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 no. Look at those ones like add origin and then you push with dash u.
Yeah, it's master.
See,
Uh, no,
see,
I'm not
man, man,
getting. Can you
man.
repeat that?
It's just to read what is like on your GitHub. They are doing exactly what you need to.
No, but that's a okay. I will do this again. Just to guys to see that I don't think this is the problem. Um, actually, let's do this from scratch. So let me just delete the dot. Let me first save this, right? Let me first save this because if I do mess things up, I don't want to lose the code. So nice. Okay, so let's delete git like this, and let's do the following. What is exactly down there?
Hit
So
init.
let's go to
Not put
Huffman.
init, you are pushing.
Oh, wait. We have a few cases there. We are
What do you
doing
mean?
the second, right?
Yeah.
Oh no, but it's the same thing. He probably will just not init. Yeah. He will
No,
just.
I deleted the git init, so I need to do this
Okay.
again.
No, no. You need cd into Ruffman first.
Oh, that's true.
Oh fuck.
That's true, my friend.
Oh my.
That's fine. Git init, and then you're gonna do. We don't need the README right now, so I will just go to Git
Man, add
status.
add everything, right?
Git
Yeah.
remote add origin.
Add. But,
No,
uh,
add everything. Add everything. That's fine. And then
no, I don't. Just git add. Yeah.
Git commit. Um, added first draft, and then Git branch -m main. Git remote add origin. And then git push -u origin main.
There is no way GitHub is wrong, man. Yeah.
Nice.
Okay, so
Okay, that's perfect.
first project,
I
and Nathan
Nice.
didn't get the joke, man.
Because a bad joke, man.
Like the rust, man.
Um okay, so what you guys can do is basically like to change the refactoring if you but if you guys are free, all of us we are free to continue doing this. So for instance, we already have the probabilities. So now the next step is to calculate entropy. Um, I don't know. It's easy to implement than to explain what entropy is. But I would suggest like entropy, Wikipedia, entropy. Okay, so the definition of entropy is a scientific concept of a measurable physical property that is most commonly associated with disorder, randomness, or uncertainty. So this is really related to probability, as you can see, like randomness, uncertainty. It is really used in information theory, which is
It's
the
you have
domain. Go.
you have like more entropy if you have like more different characters there.
I don't know. Don't remember anymore. Uh, probably. Oh,
The more
okay.
unique ones that you have.
Okay, so this is to calculate is really easy. For each probability, for each probability in our probabilities, right? You pick the number of the probability, and then you multiply by log and the log of the probability in base 2. I don't necessarily remember, and this is also negative for some reason. I don't remember why this is what it how it this is what it is, but I do remember that this is correct.
We probably have on the Wikipedia for Ruffman.
Um, do you think so? Let's
I
see.
saw
So
it.
Huffman
Man
Wikipedia,
and code.
Huffman coding.
Probably.
Yeah, it's over there.
Where?
Contribute.
H
Where? Oh,
down there.
parados. Oh, down there.
Down.
Oh, here.
Entropy. Yep.
The known probability. The entropy is the weighted sum across all symbols with non-zero probability of the information content of each symbol. Oh, so this is where the minus came in.
By the way, what is that base technique? Oh, okay.
Is explaining. Oh, this is an awesome visual representation of what we will be doing.
Wait, video?
Yeah.
Oh,
Visual.
Visual representation. Because this is the initial set of symbols, the one here. You see,
okay.
this is the final product, the 8.
Oh wait, that's a messed up phrase, man. Okay, but can you
So
do the
okay, so the first step that you need to do is to count the how many times. So this is how many times the thing occurred. So for instance, we have two C's, we have six B's, we have 11 A's, and so on and so forth, right? And then you start combining, you start gluing, okay? You start gluing the most the lowest ones. Is that right, Paradas? I don't
Yeah,
remember anymore.
the like you. I think it is.
Okay, so take for instance this
You
2 and 3.
combine the closest.
Yes, you combine the closest. Yes, so the closest one. So 2 is closest to is the no, it's not the closest. Is the least amount of them. So the two
That's why
uh,
you need
the
a.
two smallest numbers are 2 and 6, as you can see. And then you combine them. You make CB with the sum of them, and you start making from bottom to top a tree. So as you can see, the next two list, and then you pick this number and you put back on the set of symbols. You see?
That's almost like a tree inverted, and with tree I mean like TRI.
Anyway, the thing is, you pick this
I don't
symbol
know.
CB, and you remove the ones that you used to make it, and then you put the sum back. So you have CB here, as you can see, and it is 8. And then you pick the next two smallest numbers, and you combine them. So it's 7 with 8, and then you make 15. And as you can see, as you just said, we are making a new tree from top to bottom. But then uh, there's a you start you so for instance, but you need to keep this organized. So for instance, when you add the 8, you didn't add the 8 at the end, as you can see. We added sorting it. So 7, 8, 10, 10, 11. And then when you put the 15 here, the 15 is now the greatest number. So you shouldn't be using it anymore. You should always be using the two smallest ones. And then you combine them, so you have underscore and D with 20. You
Uh,
put this combination back on this. So
okay,
now you have,
that's pretty easy.
and then you have ACB, and this couple. And then you combine 11 with 15, and then you're going to have 26, right? And then you put this back on here. So now these are the two most common symbols, underscore D and AECB. This is going to be the ones that will occupy the last amount of bits, these combinations. So as you can see, the underscore bit 0, the underscore 00, the D 01, the A 10.
I think one nice thing to say is that every time you go left on the tree, you add a zero. Every time you go right, you read a one.
Oh yeah,
So, for
every time you
example,
go to the so
you want to get underscore, so you go left left, so it's 0 0.
look
And you
at
get the
look at
D
this final
left
tree.
right.
No, I will try to translate what Parada just said. Look at this final tree. Every time you go left on the tree, this is gonna represent the symbol 0.
Oh, okay, I can see.
And every time you go to the right is the symbol 1. So in order to decide which symbol underscore will be, you go left left. So it's gonna be 0 0. And so on and so forth. And then this is the table. This is going to be inside the header of our, because what we're going to make a file called dot.
Wait, but that is something
It's
strange.
going to be like this. This is going to be like we're going to have Dom Casmurro dot drn, for instance. And then inside the table, inside the header of this file, we're going to have this and this.
Exactly.
And then you use this to translate this back to this. Okay?
Wait, can you repeat that last part?
Yes. So what are we going to be sending to the decompressor? Four things. Four things we're going to be sending. This table, a special number that I will explain further what it means. This amount of bits. So this is not numbers. This is not the number one. This is the bit one. Okay. And then you and then do you agree that this maybe will not be a multiple of 8?
Yes.
Yep.
Then we need to add
Exactly.
extra zeros at the end. But we need to inform the decompressor that these zeros are not symbols. And this is what the special number will do, the magic number after this table. So it's going to be this table, and then a number that will represent how many bits at the end of the payload the decompressor
So
should
the
ignore,
padding bits.
the padding, and then the payload itself with the padding. And then you use the magic number to remove the padding, and then you use this to translate this back to this. And that's it. That's the Huffman algorithm.
That's actually really nice.
So as you can see, especially the decompression is pretty straightforward, right? So it's really easy. It's basically a dictionary.
Yeah.
You start reading. Oh, oh, and that's the thing that I think it's important to figure out, to see by yourself. It's impossible to confuse the symbols. Every
Yeah.
time you see
This is
two
nice.
zeros in a row, this will be the underscore, and this is a property of this tree.
Oh,
Every time you see two zeros in a row, this always will be underscore. Every time you see zero and then a one, it will be a D, and so on and so forth. So you will never be confused. Oh, this is a E or this is a C. I don't know. This is a property of this tree.
like you see a one, and then you already discard all the first two. Then you see
Yeah.
another zero. Then it's already a. Like you already know.
Yeah, yeah. So this is a really cool property of the, and there's other compression algorithms that exploit this tree structure. That actually are, but it's pretty smart, right? When I discovered this, like I don't know, a year and a half ago, man, Huffman was a smart man because
Hey Lance,
this,
but we need to wrap up, man.
oh yeah.
Yeah, I also need to go.
Okay,
But
so
anyway, now we do have a Rust implementation. Nathan, if you want to, I don't know, rename the files, rename the functions, feel free to do that
yeah,
because I know you like that. I know you like to do that.
yeah, but if I have the time, I will do it. Oh, eight, and the next one we can also like rotate who is driving.
Oh yeah.
Uh, yeah, I think that's
Nice.
it. Let me just like finish the string already.
Oh, we are still streaming.
Yes,
Okay, I thought
that's why
you
I'm
finished.
here, man.
I